Recall from the rock cycle that sedimentary rocks form when the products of weathering are transported to a new location where they are deposited and eventually lithified into solid rock. Weathering, which begins the process, can be either mechanical or chemical. When rock undergoes mechanical weathering, such as frost wedging, it is broken into smaller and smaller pieces. Where steep, rocky slopes occur, frost wedging may generate large quantities of angular rock fragments that accumulate to produce talus slopes. Chemical weathering occurs only to those portions of a rock that are exposed to the elements. Breaking rock into smaller and smaller pieces increases the surface area exposed to the elements and therefore increases the rate of chemical weathering. Whereas mechanical weathering breaks rocks into smaller fragments without a change in composition, chemical weathering alters the chemical structure of minerals by removing and/or adding elements. Let's consider the chemical weathering of the common igneous rock, granite. Chemical weathering of the potassium feldspar component of granite is as shown. The most abundant products of the chemical weathering of the feldspars are clay minerals, which are the major component of the most abundant sedimentary rock, shale. In addition, potassium ions and silica are removed from the feldspar structure. These products, which are dissolved in water, will eventually precipitate to produce other sedimentary rocks. Quartz, the other main component of granite, is very resistant to chemical weathering. Hence, with the decomposition of feldspar, quartz grains are released. These resistant grains may accumulate as dunes, beaches, or other sandy deposits. This table lists the weathered products of some of the most common silicate minerals. Erosional agents such as running water, wind, waves, and ice remove the products of weathering and transport them to other locations. Eventually, these solid particles and dissolved substances called sediment are deposited. Next, the sediments undergo lithification, meaning conversion to rock, by compaction, and/or by cementation, as percolating water coats the sediment with mineral matter and gradually cements the particles together. The result is sedimentary rocks, such as shale, sandstone, and conglomerate. Some sedimentary rocks are not compacted or cemented, but form as solid masses of intergrown crystals. Rock salt is one example. The products of weathering include materials that originate and are transported as solid particles. These particles are called detritus, and the sedimentary rocks they form are called detrital sedimentary rocks. Two minerals are especially common in detrital rocks, clay and quartz. Geologists use particle size to distinguish among detrital sedimentary rocks. The common sediment name for all particles larger than 2 millimeters is gravel. When gravel-sized particles predominate, the rock is called conglomerate if the particles are rounded, and breccia if the pieces are angular. The particles in conglomerate become rounded as they are transported, most frequently by streams. The angular pieces in breccia indicate the particles were not transported very far from their source prior to deposition. The common sediment name for particles between 1/16 of a millimeter and 2 millimeters is sand. And sandstone is the name given rocks when sand-size grains dominate. Because it is very durable, quartz is the predominant mineral in most sandstones. When substantial quantities of feldspar are present in sandstone, the rock is called arkose. The presence of abundant feldspar suggests there was little chemical weathering of the sediment, something we might associate with a dry climate. When the tiniest silt and clay-sized particles predominate, the common sediment name is mud. And shale or mudstone is the name given the rock. In a non-technical context, the term shale is used for all fine-grained sedimentary rocks. Because shale crumbles rather easily, it forms gentler slopes of weathered debris. By comparison, outcrops of more durable rocks, like sandstone, produce bold, steep cliffs. Unlike detrital rocks, which form from the solid products of weathering, the source of sediment for chemical sedimentary rocks is material dissolved in water. When material in solution precipitates, it forms chemical sediments, which become rocks such as limestone, chert, and rock salt. Precipitation of dissolved material occurs by inorganic processes such as evaporation, temperature change, and chemical activity, or by life processes of water-dwelling organisms. These materials are called biochemical sediment. Limestone, the most abundant chemical sedimentary rock, is composed chiefly of the mineral calcite. Most limestone has a biochemical origin. Examples include coquina, which consists of shell fragments. Chalk, which is made of the hard parts of microscopic marine organisms. And limestones that originated as coral reefs. A limestone with an inorganic origin is travertine, which is often seen decorating caves. Chert is the name used for a number of hard, compact rocks made of microcrystalline silica. These rocks may have either an inorganic or a biochemical origin. It usually is not possible to determine this by looking at a hand sample. Evaporites form when evaporation causes minerals to precipitate from water. Such minerals include halite, the main component of rock salt, and gypsum, the main ingredient of rock gypsum. Thick evaporite deposits may form when seawater evaporates, or on a smaller scale in desert basins. Click on the correct rock name that fits the above description.